NASA's Voyager 1 spacecraft, which currently holds the distinction of being the farthest human-made object from Earth, has fascinated people across the globe. For nearly 50 years since its launch, Voyager 1 has sent back vital data from the edge of deep space, expanding humanity's understanding of the universe. However, the probe's recent transmissions have displayed unusual anomalies that have left scientists perplexed. These puzzling signals have stirred intense discussion, raising questions about whether these are simply technical issues or signs of something far more extraordinary, possibly even extraterrestrial activity. Join us as we explore these mysterious messages and consider what might be hidden within the vast reaches of space. The natural human drive to solve mysteries has long fueled our desire to explore the cosmos. This deep curiosity laid the groundwork for daring missions like Pioneer 10 and Pioneer 11, which were among the most ambitious space projects of their era. Voyager 2 lifted off from NASA's Kennedy Space Center on August 20, 1977, marking the beginning of a revolutionary period in space exploration. Shortly afterward, on September 5, 1977, Voyager 1 was launched, starting a journey that would take it past the outer planets and profoundly reshape scientific expectations. Each spacecraft weighing approximately 721 kilograms, similar to a small car, followed separate trajectories at different speeds. On December 15, 1977, a key milestone occurred. Voyager 1 surpassed its twin in distance traveled. Owing to its unique route from that point on, Voyager 1 became a crucial instrument in expanding our knowledge of the cosmos, delivering discoveries that have reshaped our understanding of space. Before diving into its recent groundbreaking findings, let's revisit some of Voyager 1's earlier landmark achievements. In 1979, while about 265 million km from Earth, the spacecraft captured high-resolution images of Jupiter. By January of that year, it had completed a remarkable 100-hour observation, producing a time-lapse video that showcased Jupiter's rotation. These 3,750 photos offered unprecedented views of the planet's volatile atmosphere and intricate patterns. During this mission, Voyager 1 also discovered an unseen ring around Jupiter and identified 2 new moons, greatly enriching our understanding of the planet's complex system. To maintain its path and avoid a collision with Titan, one of Saturn's moons, the spacecraft performed several course corrections. Afterward, the mission's focus shifted beyond the solar system's planets as the probe ventured into interstellar space, traveling at an astonishing speed of 325 million kilometers annually. In January 1990, Voyager 1 began its mission to examine interstellar space, pushing beyond the outer edges of our solar system. During this phase, it accomplished several exceptional tasks, such as discovering 4 additional moons, Memes, Enceladus, Tuz, and Rhea, and capturing some of the most iconic images of the solar system's distant regions. On February 14, 1990, from about 6 billion km away from the Sun, Voyager 1 took the famous family portrait, a mosaic of photographs depicting the inner planets. This series of 60 images was added to the probe's expansive catalog, which already featured hundreds of photos from encounters with gas giants. Voyager 2, meanwhile, achieved remarkable milestones. On its journey, it recorded wind velocities on Neptune that exceeded 2,100 km/h, about 1,300 meters per second, the fastest atmospheric winds ever documented in the solar system. It also studied Triton, Neptune's largest moon, where temperatures dropped to a frigidus 391 degrees F, making it one of the coldest known places. Triton showed evidence of icy geysers ejecting nitrogen gas and frozen particles up to 5 kilometers high, revealing its dynamic geology. These astonishing discoveries significantly deepened our Insight into the diverse and dynamic conditions found at the solar system's outer boundaries. The contributions of Voyager 1 and 2 have been transformative, revealing unexpected activity on moons once believed to be dormant. This prompted a reassessment of earlier theories about their geology. Voyager 2, in particular, made history as the only spacecraft to date to visit both Uranus and Neptune up close, an unmatched achievement. NASA extended the lifespan of these historic missions through clever methods such as deactivating non-essential systems to conserve energy. The mission is anticipated to last until 2030, marking the end of a remarkable era for the teams who have dedicated their lives to it. The design and engineering of Voyager 1 and 2 were groundbreaking. Built to rotate slowly, they minimized image blur during movement. Even before arriving at the outer planets, the spacecraft began sending back detailed photos of Jupiter, revealing swirling cloud patterns and the massive Great Red Spot, a storm system that has intrigued scientists for decades. One of the most exciting findings was the detection of active volcanoes on Io, one of Jupiter's moons. The spacecraft's instruments detected strange readings which were later confirmed by images showing giant volcanic plumes and a landscape dramatically reshaped by eruptions. One eruption was found to be 1,000 times more powerful than the Mount St. Helens explosion, covering an area nearly the size of France. As the probes continued their mission, they were gradually powered down to conserve energy for interstellar travel. Interestingly, they didn't capture photos of Mercury or Mars due to technical restrictions. NASA later launched additional landmark missions, including Pioneer 10, Pioneer 11, and New Horizons. On February 17, 1998, Pioneer 10 overtook Pioneer 11 as the most distant probe from Earth. Nonetheless, Voyager 1 continued its journey and, after 14 more years, officially entered interstellar space on August 25, 2012. A major factor behind these mission success was the strategic use of gravity assist maneuvers, which slingshot the spacecraft toward their targets while conserving fuel. Rather than relying solely on propulsion, they used the gravitational pull of planets to gain speed and adjust direction. This allowed them to cover immense distances with minimal fuel. As Voyager 1 approached Jupiter, its gravity boosted the spacecraft's velocity. Precise calculations were essential to avoid any dangerous deviations in trajectory or speed. These gravity assists enabled the spacecraft to expertly navigate the solar system. Voyager 2 likewise used gravity from Jupiter and Saturn to reach Uranus and Neptune, demonstrating the method's effectiveness. Reflecting on these extraordinary missions, scientists are eagerly awaiting more information from the curious signals Voyager 1 has recently detected. The probes continue to explore beyond the solar system, collecting data from the outskirts of planets like Jupiter, Saturn, Uranus, and Neptune. Voyager 1's time-lapse images captured 10 eruptions on Jupiter, revealed additional moons, and found a previously unknown ring around the planet. These findings greatly enriched our knowledge of the Jovian system. Voyager 1 also discovered 4 more moons of Saturn, Mimes, Enceladus, Tuz, and Rhea, and sent back remarkable pictures of the planet and its rings, offering new insights into its complex composition. Its flybys of Uranus and Neptune provided critical data on their atmospheres and moons, improving our understanding of the solar system's distant realms. After completing their planetary missions, the probes set course for interstellar space, where they continue gathering valuable scientific information. This ongoing work extends our perspective on what lies beyond our solar neighborhood as we await further updates on Voyager 1's unusual transmissions and what they might mean for our understanding of the cosmos. The inspiring journeys of these spacecraft continue to captivate both scientists and space enthusiasts alike. Their accomplishments remain essential in advancing human knowledge and pushing the boundaries of space science. The Voyager missions gave us unparalleled views of the solar system and beyond, producing iconic imagery and groundbreaking data. In addition to their scientific contributions, the spacecraft carry a cultural artifact meant to share Earth's story with any intelligent beings that might encounter them. The Golden Record contains greetings in 55 languages, music from around the world, and natural sounds like rain and whale calls. This interstellar time capsule represents humanity's hope that intelligent life beyond Earth might one day find and comprehend it. Voyager 1 and 2 were equipped with a wide array of scientific instruments that revolutionized our understanding of space. These included magnetic field detectors, plasma wave analyzers, and imaging equipment, all of which provided essential insights into space environments. The magnetometers helped reveal the magnetic fields of the outer planets and how they interact with their surroundings. Plasma sensors helped explain how solar wind influences planetary atmospheres. One of the mission's most important successes was mapping the edge of the heliosphere, a region filled with solar particles and magnetic forces that envelopes our solar system. As Voyager 1 approached this boundary, it detected a transition from solar particles to interstellar matter, providing crucial data about how this boundary shields Earth from harmful cosmic rays. The spacecraft identified a point called the termination shock where the solar wind slows and thickens. Beyond this lies the heliosheath, a turbulent zone where solar and interstellar particles collide, creating a rich and dynamic environment. Voyager 2's trip added further depth to our knowledge of the solar system's fringes. Its observations, especially of Uranus's magnetic field, which was found to be tilted in unexpected ways, challenged existing models and spurred new investigations into planetary magnetism. These missions not only advanced scientific understanding but also ignited public imagination. The stunning imagery of distant planets and the compelling stories of the spacecraft have inspired generations. Iconic photos of Saturn's rings and Jupiter's great red spot remain among the most memorable images in space exploration.